Hi, welcome to the Scan and Find It Evaluations Lab. Thank you for joining. My name is Wissam Abdel-Zahir. In the next few minutes, I'll walk you through a compressed, hands-on look at how we automate trust in a wellness app. Scan and Find It lets users scan food, understand nutrition guidelines, and chat with an in-app AI wellness-focused assistant. At large scale, a bug in goal math is a trust and usability problem, and a wrong scanner or safety reply is a safety problem, not an edge case. Some ground rules for this lab. We use synthetic data only. This is a general wellness education, not clinical advice, and the product is not FDA approved. What you're about to see is how we verify that promise in code through automated checks called evals. These are alignment checks, not legal proof of compliance. An eval is a repeatable automated check that scores system behavior against expectations without manual QA on every release. So a unit test asks, does this function return X? And an eval asks what system behavior stays acceptable at scale. One common goal is catching patterns that would mislead users if they shipped. If we only unit tested one 36-year-old woman, we'd miss population level bugs, BMI, adjusted weight, pregnancy add-ons, sedentary versus very active drift across thousands of profiles. So this lab covers two kinds of evals. Population nutrition evals is the first one. So we have synthetic adults generated from distributions derived from published National Center for Health Statistics. So these aren't real participants or users. These are synthetic profiles, not population representative research samples. We check that calorie targets land in plausible DGA-derived reference calorie ranges from DGA 2020 to 2025. Age, sex, activity, not individualized clinical prescriptions for at least 85% of the cohort. So that 85% is an engineering regression gate. Is chosen to catch cohort level drift without demanding perfection on every synthetic profile. It's a plausibility gate, not clinical validation. It's quality control checkpoint, so it prevents changes from moving forward if they introduce regressions. So if something previously worked correctly, now it fails or performs worse, this would catch that. And then the second evals that we have are the agent routing evals. Like I showed you, we have our chat agent, and it routes to different skills or tool sets. So this evaluates whether that routing works. We do it offline and online. Scripted user questions whether every assertion must pass. So one wrong scanner or one minimized safety reply is too many. And passing is binary per check. So there's no we're good at 95%. So no um safety or routing regressions getting averaged away. So for the first exercise, we have our population eval. This is a lab that you can do self-guided at home. So right now we're just doing a quick version of it. Um, You can dive deep and read through each line if you'd like, but right now we're going to go through these two examples, the population evals and the agent evals. So the population evals, like I said, this is to make sure that the calculations that we're doing to provide those nutrition goals are plausible based off of those DGA guidelines. And if we click run, we'll see that these evals pass. So we run these before in production, before we deploy anything new to make sure that we haven't broken any of our calculations or any of our agent skills or tool sets. Here we have our population. The sample is 200 synthetic adults and 100% fall within that DJA band. So it's plausible before we can go to the next step. And then we also have our hand curated personas. These are the same. We can rerun our seed multiple times, getting you 200 personas each time. But these will always stay the same and these also pass. And let's go back here. So yeah, we ran that. Mhm. So let's take a look at the synthetic personas. So this is an educational model at BMI 30 or higher. We have here, for example, this short, heavy female. We use adjusted body weight for BMR because some nutrition practitioners apply it to reduce overestimation in certain predictive equations. And protein targets here still use actual body weight, which many frameworks also do. So this persona is exactly the kind of edge case a population eval is meant to catch. So passing tells us outputs are plausible and the algorithm hasn't drifted catastrophically. It doesn't establish medical validity or real-world outcomes. Marginal sampling from published stats also does not preserve full survey covariance. Fine for workshop plausibility, but not population research claims. So this population check that we just ran, this is good for layer zero. Before we go forward, you know, to large amounts of users. So the second exercise is the agent routing eval. So we have our agent and we have our router. For that agent, the in-app assistant runs through safety gates, intent understanding skills, tools, and then a response all on the server. So in production, we log hundreds of cases. Here we're teaching pattern matching instead of live LLM, which is what we use in production. Now we run our other workflow. This is our agent eval. 5 passed, 0 failed. These are the cases we're testing to make sure that the router sends the user to the right tool or to the right data, um, given their question. So in production for a deploy gate, any failure blocks release. 267 offline cases, with 0 allowed failures. And then here for navigation, scan my food, it should still send to the food scanner. Um, Not the med scanner or the plastic scanner. For a demo, it looks fine, but an eval catches the wrong scanner going forward forever. Artificial food coloring. Is artificial food coloring safe for kids? If we ask that to the agent and it goes to the camera scanner, it would feel helpful, but it would be wrong. That's an integrity failure. The user asked the safety question, not scan this package. So the expected outcome is none in terms of routing. It would stay in the chat. Why not pass at 95% of routing cases? Because one wrong scanner or one wrong safety reply is one too many at scale. And offline evals use mocks, so they can be fast and deterministic. But in production, we also use live staging evals to catch model wording drift that mock evals can't see. I hope that can show you a little bit about how evals are how we verify integrity at scale. First, we trust the math using the evals, and then we trust the agent contracts and treat everything else as what if until those gates pass. So the full lab is available with the architecture diagrams, and all 10 impact cases. In the public repo, the README has the steps. It's self-guided. You can follow the facilitator guide, and I'll be adding the links as well. So thank you for watching. Please import the repo, run the evals for yourself, see